Hi, my name is Randy. Je parle français depuis un jeune âge. He aprendido español por 4 años. أتكلم اللغة العربية لأن لغتي الأم. وخوش وإيدين جونكوين. Motokengo o Manabitai. I was lucky enough to grow up with 3 languages. And every new one since has been easier to learn. This is thanks to cross-lingual transfer. And it turns out the same principle applies to language models. The paper I chose is focused on this, and it's called A Post-Trainer's Guide to Multilingual Training Data. It studies exactly how models transfer skills across languages. It tests models on summarization, instruction following, and math. They found that different tasks benefit differently. Larger models transfer more efficiently, and multitask training is unstable at a small scale. Our expansion will focus on mitigations to those limitations. Now, before, I have a particular approach to AI research, and it's to first see how humans do it. What humans reveal about how we process language often gives us clues about how models might as well. One example comes from a 2016 paper on cross-linguistic structural priming. The researchers found that multilinguals don't keep separate grammars for each language. So when structures match, they share one syntax. For example, in English we say, Cohere released a model that amazed researchers. In French, we will say, Cohere a publié un modèle qui a étonné les chercheurs. Different words, but the same relative close structure. Humans automatically transfer it. For AI, this suggests we could train models to share this syntax, and not just vocabulary. Instead of overlapping sort of like word embeddings, we could emphasize dependency arcs or structural frames. Which means, during training, we could do structure-aware sampling, so we could oversample shared syntax, and we could also play around with the objectives. So we could do syntax-anchored objectives where we add auxiliary losses predicting parse trees, and that would potentially stabilize multitask training. However, it might not always work, because languages with very different word orders could still cause problems, like English and Japanese, but even discovering those limits would teach us something. And if it works, it would reduce the instability small models face. Another particular approach I have to research is to make sure I take advantage of as much of what I currently have. In this case, it would be Cohere's ecosystem. So I would pick a paper from Cohere's ecosystem, which in this case, the one that connects directly is one tokenizer to rule them all. This paper shows that a single tokenizer can adapt across languages. Instead of building one for each language, that's like giving models a shared alphabet. Now, to connect it back to our initial paper, we can maybe, when the transfer is unstable for small models, what if part of the solution was at the token level? And so here's how I would explore it. One, I would map which structures transfer well under a single tokenizer. I would then let the tokenizer adjust itself, especially for low resource languages. And finally, again, on the idea of Cohere's ecosystem, I would test it on benchmarks like AI Expanse or Global MMLU. This way, syntax level transfer and tokenizer level plasticity reinforce each other. So, in conclusion, I started by showing how human research and research focused on human linguistics could influence AI. Then, I looked into how we can benefit from Cohere's ecosystem, so that I'm only like one phone call away from another experts. And that's what excites me about this Scholars program. It's the ecosystem, the team around me, and the opportunity to work and combine those human insights. Finally, I want to say, arigato gozaimashita. Thank you for listening.